and only really talked about design insofar as it illustrated some of the things we might do with those technologies. This year, I want to do something different. I actually want to talk mostly about design and only about technology insofar as it provides a context and influences design decisions. I don't imagine this is a kind of controversial thesis for this audience. We're all here because we understand that font technology is important. And if we make fonts, I'm sure you've had the experience of the font technology influencing some of the decisions you make about design. It provides a framework within which you think about design. By technological circumstances, I don't just mean things like the font format itself, but also the circumstances in which a font will be used. So the operating system, the applications, and in the case of the project I'm going to be talking about today, specifically the user interfaces. And those circumstances are the result of decisions, design decisions, that have been made elsewhere by other people, sometimes not necessarily good decisions. Design is a kind of thinking, and so doing type design is thinking within technology. And that means to me that if the technological circumstances change over time, we can and sometimes probably should rethink our designs. And so what I want to talk about today is a particular project that's been rethought a number of different times as the technology have changed within a fairly rapid period of time. So this is a project that's occupied me for about 10 years now. And in that time, the technology has changed significantly. In 2009, I got an email from Ali, who is a project manager at Microsoft Typography, who likes to keep me busy. And he sent me this basic one-line email that said, can we do something to improve Indic typography in the Windows user interface? And I wrote back and said, probably, what are some of the problems? And he sent me a lengthy document illustrating all of the problems they were having. Basically, what had happened is that as Microsoft had added support for Indic scripts in the shaping engines and in the operating system, they had licensed a lot of different fonts, basically so that they would have at least one font for each of the scripts that they were supporting. And because they only had the one font, that by default became the font that was used in the user interface. Now, these are not fonts that were designed for user interfaces. They hadn't been optimized for screens. Some of them had been made originally for document use. Most of them were low contrast, what we would think of as harmonizing with the Latin sans serif. But they were very disparate. So they had quite mixed quality, some of them better designs than others. They had different scaling factors. They didn't harmonize in terms of kind of weight or scale with the Segura UI, which is the Latin and European language user interface font. And they had inconsistent vertical metrics, which in the user interface meant that things tended to kind of either force the user interface to rescale in ways it wasn't designed to do, or you would end up with bits of the Indic scripts being clipped, so they actually effectively became unreadable in some cases. So Ali and I looked at all these problems together and decided that, yes, we could do something about this. And so this was the beginning of what became Nirmala UI, which is a family of fonts now in 3 weights that support 13 different Indian scripts. The original project brief was only 6 scripts, so we got this thing. We were going to support Bengali, Devanagari, Gujarati, Malayalam, Odia, and Telugu. And we were going to target specific UI localization. So the localization teams at Microsoft had translated the English language user interface strings into these various languages. And we received those as a set of spreadsheets. So we were actually able to analyze the translations, do things like looking at frequency of characters, frequency of combinations of characters in consonant conjuncts, the sorts of things we needed to do to plan what the glyph sets of these fonts were going to be. We wanted to maximize the legibility. Now, the first step to maximizing legibility, make something bigger. So the idea was, how big can we make the core forms of letter forms of each of these scripts within the vertical space that we had to work with to make things as legible as possible at what were in fact very small sizes. So at the time, Microsoft was still very much focused on 96 DPI displays. There are still a lot of them in use. There's still quite a lot of them in use today, although we tend to think of that we've kind of moved into high-res environments, but there's still a lot of lower-res screens in use around the world. And so we're targeting 9-point at 96 ppi, which is 12 pixels per M. And we actually, in some parts of the Office UI, was going down to 8-point. We were going to hint for screen legibility because we're targeting both the older GDI environment and the D-Write ClearType renderers. So a stronger level of TrueType hinting than you would typically apply today. Harmonize the style, scale, and weight to the Segur UI fonts, and use the vertical metrics of the Segur UI fonts. And if you know anything at all about index scripts, this is the line that should alarm you. A lot of index scripts make use of vertical space much more extensively than European scripts do. A lot of the scripts, particularly South Indian scripts, will display combinations of consonant signs with subscribed letters. So they actually have the main base letter and then a smaller form consonant underneath it, and they might even have a vowel sign or something else underneath or around that. And so if you imagine the typical vertical metrics of a Latin sans serif font, and then imagine trying to squeeze all of the Indian scripts with all their variety into that very narrow amount of space, you can sort of see that this was the biggest challenge. And the reason for this is that all this was done in preparation for Windows 8. So we started looking at the problems in 2009. Windows 8 shipped in 2012. So ostensibly, we had a 3-year window. In fact, as you can imagine, if you're making fonts to ship with an operating system, you have to get those checked into the operating system build very early on. So in fact, we only had a little less than a year, really, to do the main design work. This is the infamous Windows 8 start screen. Windows 8 was a brave idea on Microsoft's part that you would have the same operating system for everything from a desktop computer down to a Windows phone. And this was kind of the entry level into it, was this start menu, which is both a UI and a kind of content providing platform, in that it was pulling stuff from the web, people's news feeds, stuff like that, and presenting it within this grid. And it is a grid, and we like grids because we're designers, and this grid is actually built outwards from the Segur UI font metrics. So it's a typographic grid, so even better. But this grid is very fixed, and we had to squeeze all of the index scripts and languages into this particular grid. I've never worked on a project that didn't expand once you got past the initial brief. So initially, we had 6 scripts to work with. Partway through the development, Ali came back and said, we really like the direction this is going in, and the localization teams for other languages want their scripts added as well. So we added 4 more scripts. We started with this 9-point at 96 DPI. Suddenly, because of things like the Windows Phone, higher resolutions became important within the focus of the project. And things like that where it says start at the top there, stuff like that was going to be displayed quite big. We would need to sort of deal with those aspects of it as well. And then there was a really nasty surprise, actually after we'd finished all of the work. So we had designed and hinted around ClearType color subpixel rendering, and just before Windows 8 shipped, some teams had concerns about the performance hits of the color rendering, and insisted that in that metro environment, what they called that grid system, they were going to switch to an asymmetric grayscale rendering, which did a very interesting thing because they were using grayscale instead of color subpixel, but they were still using the subpixels for positioning. So the spacing was based on the subpixels, but the rendering was grayscale. And what this meant was all our careful hinting and design that we'd done to have everything have a nice, strong stroke density. Suddenly everything looked like it was on a kind of 90% gray scale. And as you went along a line, the glyphs were varying quite significantly in their density. So this is kind of the approach we took. So maximize the legible size per script. So get things as big as we could within the vertical metrics. Design close to the full pixel in the y direction. So vertically, we're actually, we're specifically targeting that 9-point at 96 dpi. We're saying, right, 12-point, we're going to design close to the full pixel height. Horizontally, we're going to go either toward the full pixel height or towards the subpixel boundaries. And that's to give us the kind of the sharpest, clearest definition we can at the target size. This is done with a certain amount of flexibility because we don't want to distort the conventional proportions of the letters in the individual scripts. We're going to match the Segoe UI weight where practical. Some of the scripts, particularly the South Indian scripts, have much more complicated forms than European scripts do. And simply, in order to be able to render those legibly, we needed to make them lighter than the corresponding Segoe UI nominal weights. The really difficult issue of dealing with this constrained vertical metrics, we were going to attack on a per script basis. So we were going to look at each script and figure out the best way to force it into these metrics. And I'll talk in detail about the compromises we had to make there. We're going to do strong y-direction hinting to force the details within the device metrics at specific sizes. So basically, at some sizes, we're using the hinting to force things within those vertical metrics. I put an asterisk there because we had another nasty surprise, which is we'd done quite a lot of the initial hinting work, and we sent the fonts off to Microsoft, and we'd done our own testing. We were really happy with how they were looking. And this is where we found out that Segoe UI has a custom VDMX table that actually further constrains the vertical metrics at some sizes. They actually shaved pixels off the height. So, in fact, we didn't have 12 pixels. We only had 11 pixels. And then finally, to fail in the best way possible. We knew we were going to have to make compromises. We knew we were going to have to do a certain amount of violence to these scripts. And what was going to be the least awful way of doing that. We had about 9 months of kind of core design work. So I contacted Fiona Ross, with whom I work with very frequently, and I said, Fiona, we need to put together a team. I can't do all the glyph work myself. It needs to be people we can rely on. So we decided it had to be people we'd either worked with before, or who, in some of the cases here, were recent graduates from the MA program in Reading. And we wanted people who were still based in the UK so that they could actually meet with Fiona on a regular basis and provide very direct feedback on the designs. I want to say a little bit of a word here about this kind of list of white people making Indic fonts. This was 2009. I think even 1 or 2 years later, this list would look very different, just because of the changes in the MA program at Reading and in terms of how much more international that has become. So there would have been a lot more Indian people on this list 1 or 2 years after we initiated this project. So this was the initial tranche of the 10 scripts we were dealing with. After we'd done all this, and still for Windows 8, Ali came back to me and said, we're interested in having something for use in larger sizes, for things like that, like word start translated into things. Can you do a semi-light design? So having done a regular and a bold, I went back and working with Neelakash Kshatramayam, who has worked with us on a lot of Indic projects. He and I together designed this semi-lightweight for all of the scripts. Since it shipped in 2012, we've since added 3 more scripts that Neil worked on. And so we're now up to 13 scripts, plus we've added, went back and added support for historical and archaic characters from the Unicode block. So initially we were targeting specific languages, now we're targeting entire blocks, including things like Vedic mark support for Devanagari. So let's talk about the vertical space issue. So you might not be aware of this. One of the ways in which OpenType is supposed to work is that you have your outlines, and your outlines are rasterized to pixels that are a given size, and then OpenType GPOS mark positioning and spacing is applied. So the rasterization happens first, and then the positioning applies. So that gave me the idea, okay, well, maybe what we can do is design the marks sitting within the vertical metrics, rasterize them, and then use GPOS to shift the marks down, and it wouldn't matter if they went outside the vertical metrics because they would already have been rasterized. That was the theory. This is a screenshot of a test we made from a Windows environment, and you see an interesting thing happens. The green arrows are pointing places where it worked. The red arrows are pointing the places where it didn't work. And what we found was we couldn't rely on things not being clipped, because some places they'd be clipped, other places they wouldn't be clipped. It depended on what else was being done in the UI in terms of elements that might cut across stuff. So we decided, okay, so we can't do it that way. Anything below, going outside of the vertical metrics would risk being clipped. And obviously, if it's something like a vowel sign, which is what the bottom mark is here, if the vowel sign is clipped, someone can't read the word. You know, they're not sure. It might even be ambiguities between it and another word. So because this is a fairly frequent combination in the UI strings we're analyzing, we ended up solving this particular one by having a special form of this letter, which was foreshortened, which allowed us then to squeeze the mark stack into the vertical metrics. The methods we used, as I said, changed depending on the individual script. So Malayalam, we made these foreshortened versions of the bases that actually float above the baseline so that we can squeeze the subscript consonants underneath. In Telugu, because of the ways in which the base and the vowel marks at the top actually merge with each other, we ended up contextually shifting the entire consonant cluster upwards. So the entire syllable jumps up. So when you're reading it, you kind of go along, and every time we have a subscript, everything shifts up slightly. So it looks a little bit odd as it kind of bounces along the line, but it's readable. Audio was one of the worst situations we had to deal with. So in the gray, you've got the base form. Like the Malayalam, I had these raised floaty forms, and that works fine if all you need to do is stick a consonant underneath it in the green there. If you then need to add a vowel sign underneath the stack, that gets pushed completely outside of the vertical metrics and gets clipped. And there's no way we could kind of reasonably squeeze it in. So what we actually do there is we contextually decompose the vertical stack into this horizontal layout, which is showing the base form, the little slash mark underneath it is a vowel killer, the second consonant, which then takes the vowel sign underneath it. If you read into scripts, you know, this isn't really readable. This is what I call decipherable representation. So someone encountering this in a word will be able to phonetically understand what the word is based on deciphering this, but isn't the normal way of writing the script. And we had to do quite a lot of this in Devanagari and Bengali as well, where the marks coming below were contextually triggering this horizontal layout. Someone on Twitter a little while ago referred to this sort of thing as a travesty, but said approvingly, the font is functional. And I think a functional travesty was basically the design brief for this project. We knew we were going to have to fail. We knew we were going to have to do violence to these writing systems in order to get them to fit into these vertical heights. And so this was the solution. And this is why I'm very ambivalent about this project. And this is actually the first time I've spoken about it in public, because on the one hand, I'm proud of the fact that we were able, in the space of about 9 months, to produce high-quality, user interface fonts for 10 major writing systems. And at the same time, I'm embarrassed about the way in which we had to do it. In August of 2012, Windows 8 rolled out to the OEM distributors. In October 2012, it shipped to the public. And in September that year, I Ali invited me to come to Microsoft to talk about the project to the localization teams. And I did a whole presentation about what we'd done. And I left them with 3 thoughts. One was that localization means more than translating UI text strings. So their job is to translate the user interface into different scripts and languages. And I said, it isn't just a question of taking these strings and putting them into another language. You have to think about how those languages are going to be displayed. Could someone get me a glass of water, please? Ideally, the dimensions of the UI elements should be localized and made adaptive. And this is what I call localizing the grid. The idea that the user interface itself needs to be made flexible so that it can accommodate all the world's different writing systems, regardless of how they use vertical and horizontal space. And the other thought I left with this, which is low-resolution user interfaces actually don't scale to high resolutions. In setting out to design for that 9-point at 96 dpi, we had created things that actually don't scale particularly well to 400 dpi screens, larger sizes. So around the same time, Ali and I started talking about, well, now we've designed this stuff, wouldn't it be nice if we actually had a version that didn't have these constraints on it? What if we could take the designs that we've made and free them from the constraints that have forced them to be a particular way, and instead make versions of them that would be useful for end users in terms of creating documents, make them so they work better at higher resolutions, larger sizes. So we began to think about creating a set of Nirmala document fonts. And we began by doing experimental versions of, first of all, the Devanagari and the Tamil to sort of see how we would go about that. I came across this quote from Tobias Freyer-Jones recently. Screen text can be treated as an optical size. And he's talking there about the ways in which, if you're taking a typeface, particularly Latin typeface, and making a version of it for screen, a lot of what you do is very similar to what you would do when making a smaller optical size variant. And it's a good observation, but I would say, based on my experience, is that screen text of different sizes on screen are also optical sizes. And on the screen, unlike print, we also have resolution into that mix as well. And so what you end up having to do to a design when you change the resolution is also a bit like what you have to do to a design when dealing with different optical sizes. When we were working on the project, I encouraged all of the designers to actually look at the kind of pixel bitmap sizes that they were designing for, to make the shapes work as well as possible, even before hinting at those specific target sizes. One result of this is if you blow up those letters, there's a certain crudeness in some of the forms. Some of the curves and proportions are forced towards full pixel or subpixel boundaries. We're looking at diagonals and noting that diagonals were sometimes lighter than we want them to be, and so we're beefing up the diagonals. So what we have at the top is the Nirmala UI Bengali regular, and what we have at the bottom is a thing that no one has seen before now, which is the Nirmala Bengali document regular. I asked Neelakash to go back and redesign all 3 weights of the Nirmala Bengali towards a higher resolution uses. And he's done a really, really nice job across all the weights. This is what they look like. So on the left is the Nirmala UI with its default vertical metrics. So really kind of compressed in. On the right is the unconstrained document version at the same physical size. I say same physical size because at the same nominal size, it actually looks like this. That is to say, it's scaled smaller on the body than the UI version. The reason for that, this was something we came across when I was making the experimental Devanagari version. As I said, we'd made things as big as possible to keep them legible in the UI at small sizes. And so we hadn't paid any attention to the conventional relationships between Latin and Devanagari size. So conventionally, if you look at print, for example, you will see that the height of the Devanagari letters tends to be sort of somewhere between the X height and the cap height of the Latin. So we decided for the document versions of the fonts, we wanted to restore that relationship and looked at the best way to do it. Now, we'd spent a lot of time hinting these fonts, and we didn't want to throw out all the hinting by rescaling the outlines. So in order to make the Devanagari smaller, we changed the units per M value of the font, increased it to 2,408 so that it's scaled smaller. And then what I actually did was redrew the Latin, because the Latin was easier to redraw than the Devanagari was. And so what you're seeing there is a custom version of Sego UI that's been designed to harmonize with the rescaled Devanagari. And so we did the same thing with the new Bengali as well. And so again, that's the UI at the top and the document version at the bottom. And because we were now unconstrained from the vertical metrics and had a smaller scale relative, we can now fit all of our vertical stacks within the new unconstrained vertical metrics. We didn't have to worry about clipping anymore, and we didn't have to do this kind of violence of decomposing stuff. And all was well in the world. And then 2016 came along, and variable fonts arrived on the scene. And so Ali and I had another conversation, which was moving forward, even though the normally UI fonts are static fonts and are going to remain static fonts for various reasons, at least for the foreseeable future, that any new scripts we added were going to be variable first. And we would tend to, instead of starting with the UI design and then later doing document versions and later doing variable versions, for now we would do the variable versions designed toward the document versions, because we are mostly dealing with higher resolution devices now, and then modify those designs to fit within the UI fonts. Weight gain in Indic fonts, Indic scripts, is sort of interesting. Things happen in weight gain that are different from the way you gain weight in European scripts. And you get some examples here, which is sometimes weight gain means an increase in vertical height that's quite significant. For other combinations, it doesn't. There are, in fact, ways you can sort of nest things in that are quite acceptable. And so you don't have the same kind of natural linear relationship across a weight range that you do in the Latin script. So even though Neil had completely redesigned or redrawn all the Bengali, we'd still inherited a certain amount from the original UI Bengali design. And we had still approached them as 3 separate weights, not as weights requiring relationship. But now we were going to move into a variable font version, and we said, well, what are we going to need to do, and can we expand the usefulness? Instead of just taking the existing weights we have and creating a variable font version, maybe we can extend the weight. And so we had the idea of adding what we were calling an ultralight. And Neil made the interesting decision to duplex the widths. So the ultralight and the semi-light actually have the same width. And so in a variable font, within that range, there's going to be no change in width as you change the weight. But once you get beyond the semi-light, then it's going to start getting wider as well. And so we were going to move into this kind of variable design space that is simply weight. It's a single axis. But even in a single axis, to make a variable font isn't just a matter of making a set of masters and making them interpolable. Designing a variable font means designing the design space. It means thinking about the relationships of all the glyphs across that space, making decisions about whether you want that to be a fairly smooth progression, whether you want that to have breakpoints along it. These are the kind of decisions you have to make. We decided we wanted to move towards something that would be a smoother transition. So the work of making the variable font design wasn't going to be simply making the outlines technically compatible in terms of interpolability, but also making them proportionally interpolable, so that as one moved across the design space, we didn't have kind of big jumps happening, or some of the bolder glyphs getting very much deeper than others. We're going to try to keep more proportionality in the relationships. So at the top we have the second iteration of the Bengali, the static document version, and at the bottom we have what Neil is working on at the moment, which is the new variable version, and then here's an overlay of them with the new variable designing the green, and the older document version in the red. The old document version in the red, particularly in the bold, inheriting quite a lot of its proportions from the UI version. And now we're going in and changing those shapes and changing those proportions to get a better variable font. And Neil working in glyphs, this is the kind of work he's doing at the moment, just making sure not only things technically interpolable, but also proportionally interpolable. Fiona and I, meanwhile, were coming at the problem from a slightly different perspective, because Neil was doing the design work. We're going to be doing the implementation of things like mark positioning and G-sub and figuring out how that should work. So one of the things we have in the Bengali script is we have a number of variants of the short I vowel sign, which is this form that reaches over the top, the ikar. And so we have different widths of it. And then we also have some different heights of it that go over the top of letters that carry flourishes on top. And so we have contextual G-sub rules that tell us which width to use based on the consonant or consonant cluster that's following it. The consonant cluster, same bases, can also take the Chandra Bindu mark, which is a nasalization mark, this little kind of half moon shape with a dot on it. And then it can also take the ikar and the Chandra Bindu together, and they have to interact with each other. And so in the bottom line, you can see what we have in the semi-light document version, where we are sometimes moving the Chandra Bindu, sometimes changing which ikar width we use, and sometimes doing both. Actually, quite a lot of the time we're doing both. So these are contextual G-pause and combined with contextual G-sub. It gets kind of complicated. One of the things I decided to do was to analyze what we'd done in the static document fonts with regard to which form of the ikar is used, and when we change the form of the ikar based on the presence of the Chandra Bindu. So the first three columns are kind of, which version are we using without the Chandra Bindu? The last three are the ones with the Chandra Bindu. I was pleased to discover that we'd actually used almost all of the same assignments across the three weights for just the ikar width, which was meant to me, okay, that means we actually have fairly good proportional relationships horizontally in the family. But once we got the Chandra Bindu in place, we were finding that we had a lot more variation. So the places where Fiona had decided that, oh no, we should use a slightly narrower ikar in this situation, was varying a lot more over the different weights. And so when we sat down to do the mark positioning for the new ultra lightweight, we decided we were going to, I told Fiona, feel free to completely change the way we'd done it before and think across the design space and the proportional relationships of the design space, such that, if possible, we can have the same substitutions of ikar widths in the presence of the Chandra Bindu across the entire design space, so that we don't have to have different G-sub at different places in the design space. Because trust me, that gets really, really complicated. And having different G-pause models across different places in the design space, really, really, really complicated. So I said, I'd really like us not to have to do that. So Fiona reanalyzed the relationships, and she decided actually what we needed was 3 extra ikar widths that would allow us more flexibility in the way in which we would handle the Chandra Bindu. So the ones in the orange there are things that we've added specifically for the variable version. So this is kind of where we are in the project. When I gave the proposal for this talk some months ago, I didn't actually know where we'd be. I was hoping to be able to show you finished fonts. I was fearing I might not have anything to show you, so I'm kind of glad that we've actually kind of managed to get far enough in that you can sort of see the process that we're going through. That as these technological circumstances have changed over the last 10 years, we've ended up revising our design thinking 3 times. So the history of typography is the history of the adaptation of design to technological circumstances. I think it's actually more interesting when the opposite happens, which it does from time to time, which is technology adapts to design. So out of this project, a couple of things occurred to me. One is that idea that I mentioned earlier of localizing the grid, of being able to have typographic grids and UI grids and stuff flex and change according to individual scripts. But if you're making a font that contains multiple scripts, in this case, what would be really helpful to support that would be to have separate vertical metrics for different scripts, and even different vertical metrics for different languages using the same script. And this isn't particular to English scripts. So you think about the uses of the Latin script, and so say English with very few diacritic marks versus Vietnamese with a lot of diacritic marks, including stacked diacritic marks. And the Vietnamese needs more vertical space than English does. And so this is an idea that I and some other people have been pushing for a while now, and it looks like it might actually happen. There's some interest from the stakeholders at Google and Apple and Microsoft. The idea of creating a new version of the base table, which would actually be able to take the existing script and language system, tagging system that we use for OpenType layout, and apply it to vertical metrics. And so we say, have a specific vertical metrics for Devanagari, or within the Latin script, have specific vertical metrics for Vietnamese. So hopefully over the course of the next year, we'll see a proposal for that and actually see that rolled into the OpenType spec. And then the other thought I had is a more recent one, which is the idea of metrics-responsive variable font axes. So variable fonts introduce the MVAR table, and the MVAR table is the metrics variations table. And in that, one of the things it allows you to do is to specify different vertical metrics in your design space. So, for example, if you have variable axes for increasing ascender height, you might also have an entry in the MVAR table that says, as the ascenders get taller, you're going to increase the vertical height to accommodate them. I began to think, well, what if we do the opposite? What if instead of having the font tell the system that we want different vertical metrics in the design space, we allow the system to tell the font, I'm giving you different vertical metrics, and now you need to adapt the design to fit those vertical metrics. And maybe that would have allowed us, if we have that, to create a single font that does both the document and the UI versions. We can have the unconstrained, nice vertical metrics in the document version, and then also within the same design, adapt to a tighter constrained vertical metrics of the UI. And so I decided I would see if I can get this to work. So here's Lawrence's Axis Praxis site and a test font I made, and I have these metrics ascent and metrics descent axes, and I can, you see that we gradually bring down the Chandra Bindu height, and then at a certain point, the height of the Ikar as well starts to change, and the Chandra Bindu actually moves slightly to the right as well. And then the metrics descent, we actually start shrinking this vertical stack, we bring it up, and we let the mark get closer and closer. And then if we reach a point at which we can't reasonably make the design squish anymore, we still have the option of contextually decomposing the horizontal form. And here's the nice animated version that Rob made for me. It's actually relatively easy. Well, it's not easy, okay. It's easy to kind of imagine the design work involved in doing this and imagine how you would actually have to build a variable font in order to do this. The tricky part of this is interoperability with the operating system. At the moment, there isn't really, we're used to the idea that an operating system can get font metrics, get the vertical metrics from the font. We don't have a model in which the operating system can tell the font hey, these are the metrics I'm giving you, and adapt accordingly. And we don't have consistency even in the way in which existing vertical metrics are used across different platforms. So although I can kind of conceive of this, actually defining the axis in a way that we can get into the specification and be usable by operating systems and browsers, et cetera, is, that's going to be the tricky part and take some time to figure out. And since this is TYPO Labs, I will end with some code, because you might be wondering, how did I build that? I built it by handwriting the XML for a TTX gsub table. So as with many other aspects of variable fonts, we're not really there yet in terms of productivity. What's happening here, I don't know if any of you ever looked at variable gsub, but what we have on the left are two lookups. And you notice the first lookup doesn't actually do anything. It's saying map from this glyph to the same glyph. And the reason for that is most of the time we don't want anything happening. What we do want to say is it's the second one, which is what does the decomposition. We're saying take that vertical stack and decompose it to the three characters to spread it out horizontally. And then on the right-hand side, we have the feature variations. And this is where we're saying on a particular axis, in this case, the metric descent axis, between a certain normalized size and another normalized size, which in this case is just the very lower end of those, that shortened descender space, apply this second lookup rather than the first one. So the first lookup is what's applied by default, but then we're saying within this space, don't use that lookup, use the second lookup. And that's what allows us to do this last minute sudden change to the horizontal form. And a special thanks to Rob McCoyne, who, despite having just flown in from the west coast of the United States last night, sat down with me and spent rather a long time debugging my variable font build process so that I could actually demo that for you today. Thank you.